Welcome to this video on the Automic Automation GCP BigQuery integration solution. In this video, we will explain the GCP BigQuery integration and what it brings to the Automic Automation user community. BigQuery is Google Cloud's fully managed and completely serverless enterprise data warehouse. BigQuery supports all data types, works across clouds, and has built-in machine learning and business intelligence, all within a unified platform. Integrating Automic Automation with GCP BigQuery allows you to run transfer configurations in your BigQuery workspace from Automic Automation. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic Automation synchronizes these processes with other, non-cloud operations. By integrating GCP BigQuery, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. GCP BigQuery processes can then be synchronized with all other environments routinely supported by Automic Automation. GCP BigQuery's role is reduced to execute the jobs. All other functions, especially those pertaining to automation, are delegated to Automic Automation. This means that we don't have to log into the GCP BigQuery environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. The Automic Automation integration provides a simplified view to run transfer configuration jobs. Automic Automation lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervise processes in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation highly simplifies the configuration and orchestration of GCP BigQuery jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple INI file containing standard values: system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository: a connection object to store the GCP BigQuery endpoint and login data, and a job template designed to trigger run transfer configuration jobs. Let's assume we're automating for 4 instances of GCP BigQuery. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create the run transfer configuration jobs in Automic Automation for each corresponding process in GCP BigQuery. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, it triggers the corresponding process in GCP BigQuery. We're able to retrieve the successive statuses, supervise the child processes in the cloud, and finally generate a job report. In Automic Automation, this job can be incorporated in workflows and integrated with other, non-cloud processes. The procedure to deploy the GCP BigQuery integration is as follows. First, we download the integration package from Marketplace. This package contains all the necessary elements. We unzip this package, which produces a directory containing the agent, the INI configuration files, and several other items, like the start command. We use the appropriate INI file for our specific platform. GCP BigQuery is a standard Automic agent. It requires at least 4 values to be updated: agent name, Automic System, JCP connection and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. We create a connection to every GCP BigQuery instance we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the GCP BigQuery endpoint. Finally, we use the GCP BigQuery template job to create the jobs we need. We match these Automic Automation jobs to the GCP BigQuery run transfer configuration jobs, reference the connection object, and run it. We're able to supervise the jobs and their children, generate logs, and retrieve the statuses. The jobs can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the GCP BigQuery integration. The agent is included in the GCP BigQuery package, which we download from Marketplace. We unzip the package, which creates a file system agent/BigQuery/bin that contains the agent files. Based on the platform, we rename the agent configuration file ucxjcidx and set a minimum of 4 values: the agent name, the AE system name, the host name and port connection to the automation engine's JCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the JR file via the Java command. The agent connects to the AE and deploys the object templates needed to support the integration, the con or connection object, and the GCP BigQuery run transfer configuration job. In our demo, we will create a connection object. Once we have established the connection to the GCP BigQuery environment, we'll create a run transfer configuration job. Finally, we'll execute and supervise the job. Let's start with the demo. Here, you see our GCP BigQuery environment. We can navigate through it using the specific option on the BigQuery site. Within BigQuery, you see the data transfers page. Click on it to see all the existing data transfers and their configurations. Currently, we have set up 4 configurations. Let's move on to the Automic System. Here, we create a connection object with specific inputs to connect to GCP BigQuery. We must enter the endpoint, which is the URL of the GCP BigQuery environment. Next, we specify an authentication type from the drop-down menu. Currently, we support the service account key, which you can provide directly as JSON or via a file path. We select the file path input type and specify the location of the file that contains the authentication information for loading data into BigQuery. If you are using a proxy in your environment, you can specify the proxy host name, port, username, and password in the proxy section. Once the connection object is defined, you can create a run transfer configuration job. Start by selecting the connection object we have just created. Following the connection input, the job requires the project ID and, optionally, the location details. You can select the transfer configuration name from a list of available options. Currently, 4 configurations resemble those previously defined. Now, you can define how you want to get your transfer logs. You can specify that all logs or only error logs should be transferred. After configuring the job, you can execute it. Let's switch to the executions view. The details pane shows the remote status field, which tracks the job status in the target environment. The execution was successful. The details panel also shows an object variable called and run ID hashtag. It helps you to clearly identify the specific job execution. Let's have a look at the reports. The report captures the information that the target system sends to Automic Automation when the job has been executed. The agent log is an additional report type that captures everything related to the job execution from the Automic Automation perspective. It lists all the parameters used to run the job and contains the response received from the target system. In our case, we see that the execution was successful. Thank you for watching this video.